A brief summary of what we talked about for section 1.2 today. The inequality. First of all, we said that, let's say 2 is smaller than 5. That's the same as saying 5 is greater than 2. You are taller than I am, or I am shorter than you are. Same statement. So notice in both cases that 2 is on the pointy side, and 5, the greater value, is on the side with 2 points. Okay, so what if we had an interval? So suppose we want to say that here's a number line, and x is between 2 and 10, and let me do 1 with the bracket. X is between 2 and 10, and what's the difference? In the first one, we have every value between 2 and 10, but 2 itself is not included, and 10 itself is not included. So let's say that if this was the amount of cash that you have, this means that you have more than $2, but less than $10. You do not have $10, you have less than $10. But in the second one, that means you have anywhere between $2 and $10. So if you check your money, you can have as little as exactly $2 and as much as exactly $10 and everything in between. So when we have parentheses, okay, the end parts are not included. But when we have brackets, the end parts are included. So a natural question is that, can I have a mixture? And the answer is sure. So suppose you have, suppose we have, let's say, something like from 2, this time 10, and everything. Okay. So let's think of this as the amount of money in a piggy bank. So the amount of money must be greater than $2 because the 2 itself is not included, okay? But you can have every value in between and 10 itself, 10 is included. Or you could have something like 2 in here and 10 in here. And so let's say now 2 is included, exactly 2 is included, but 10 is not included. 9.9999999 is included, but 10 itself is not included. Of course, with money, we don't have 9.99999, but I think you get the idea. It's the idea of some value to be included or not included. All right, so how can I write those values in 2 different forms of inequality and, let's say, interval notation? So for example, if I have x between 2 and 10, so in interval notation, that is saying between 2 and 10. If I have x is greater than or equal to 0, but smaller than 20, I can rewrite that as 0 all the way to 20. But 20 is not included. I did not have the equal sign in here. If I have x greater than 1, smaller than or equal to 4, then I have 1 to 4, 4 is included. If I have x is greater than or equal to 1, smaller than or equal to 5, then I have 1 to 5. Oh, can we have a statement that has more than one part? It has 2 of these, sure. So suppose we have, let's say, x is greater than or equal to 1, smaller than or equal to 2, or x is smaller than 5 and smaller than, x is greater than 5 and smaller than 10. X is greater than 5 but smaller than 10. Sure, I can write that as from 1 to 2 together with, or union together with, from 5 to 10. And suppose I want to show this in number line, I can say from 1 to 2, and then I can say from 5 to 10. The other thing that we talked about is to find the domain of rational function. So domain of rational function, also named as, finding excluded values, saying find excluded values. And that's actually quite simple. Suppose we have f of x equal, say, 5 over x plus 1. Well, we know when x is -1, 5 divided by 0 is undefined, because when x is -1, the denominator will be 0. So we are going to just go ahead and say that the domain is the excluded value. X cannot equal -1. Let's do something a little bit harder. What if I had g of x equals x plus 2 over x squared minus 25? And I want to know what values make the denominator 0. So 2 ways of doing this. In one way, you can say x squared minus 25 equals 0. And x squared equals add 25 to both sides. Then take square root of both sides, and you have x equals plus and minus 5. You could also use factoring. You could say x squared minus 25 equals 0. This is difference of 2 squares. So x plus 5, x minus 5 equals 0. So x equals -5 and x equals +5. Okay, so as you can see, I got the same answer. And so we can say the excluded value, x cannot be -5 and x cannot be +5 for the domain of this rational function. The other thing the last thing that we talked about, I believe, was that, say you have a set. Let's call this set A. And this set has members 1, 2, 4, and 5. So these are the members of this set. So I can say that 1 is in A, or 1 is subset of A, this symbol right here. 1 is in the set A. I can say 2 is in the set A, but 3 is not in A. 7 is not in A. All right. And one last thing that I want to talk to you is the domain, the idea of the domain. Remember that the domain is all input and range is all output. And usually input in math, we use X, but it could be T or something else. So for example, let's say that somebody's getting paid $10 an hour to work for a day. So F of T is 10T. If this person works 0 hours, gets paid nothing. 1 hour is $10, 2 hours, $20, and stuff like that. So then let's say this is for daily. Okay, so what would be a reasonable domain for this problem? That t must be between 0 and 24. Why is that? Because you don't have more than 24 hours in one day. So we call that reasonable or appropriate domain. Once again, the important thing is to remember that the domain is all sets of values for input, and the range is all sets of values for output. Okay, thanks.